Hey there, Kipsters. We are looking at objectives 3B.2 through 4. It's all about slope. So, first I just want to refresh our memory about what slope means and what are the different types of slopes. So, in a nutshell, slope is a measure of steepness. It's telling you information about how steep a line is. And one way you can think about that is it's telling you how hard is it to bike ride up or down a hill. And so this will get to my next part, which is different types of slopes. So if I'm on a bike, bear with my ant-looking bike. If I'm on a bike and I'm going uphill, I'm up on a positive slope. But then if I hit the point and now I'm going downhill, I'm then on a negative slope. And all this is going, of course, from left to right. But then if it gets really flat, we're going to call that a zero slope. It's not positive because I'm not going uphill. It's not negative because I'm not cruising downhill. It's in between, so that's a zero slope. And the last one is one hill that I would never be able to get up, which is a vertical hill. And we call that undefined. So knowing these four types is going to help you as we actually learn to calculate slope in different ways. If you know that using your left arm, a line that goes up from left to right is positive, a line that goes down from left to right is negative, a line that's completely horizontal is zero, and a line that's vertical is undefined. So first I want to talk about how you can calculate slope using something called the counting method. And it's called the counting method because basically you're going to be counting two things. Because you know that slope is really the relationship between the change in y over the change in x, which is another way to say it's really rise over run. So in order to find the slope of this first line, we'll call this line A, I'm going to find usable points on this line and then go from there. I know that this line I can start on the x-axis and go, all the way up to this point on the y-axis to find the slope. So I'm going to find the rise, which means how many spots do I need to go directly up? That's 1, 2, 3, 4, 5. The rise is 5, over the run, which is 1, 2, 3. The run is 3. I cannot simplify that fraction, so this line has a slope of 5/3. Second, I'll look at this line, we'll call this line B, which I know in advance is a negative slope, because with my left hand, my left arm, if I look at this, it's going down from left to right. So this is going to have a negative slope. I'll first figure out my usable points. I see this point on the y-axis. I see this point on the x-axis. I could also use that point. I guess I'll just use those first two for now. I'm going to find the rise first. So starting here, the rise is going down 1. So the rise is negative 1. And the run is going 1, 2, 3, 4 over. And so the run is 4. And so the slope of this line, which cannot be simplified anymore, is negative 1/4. It should make sense that it's negative because I know the line is going from left to right downhill. And the slope is negative 1/4. Now I'd like you to try some guided practice. And please find the slopes of these two lines. This first line, we'll call this line C. I'll give you the usable point of, you can start at the origin and go to point 4, 4. The second line, we'll call this line D. You can start here on the x-axis. And you can use this point, or this point, which is not perfect, but I'm not perfect with Smartboard. So please find the slope for C and for D. Press play after you've tried and are ready to check your answers. Okay, you tried to find the slope for C. Let's now check what you've done. Going from the origin up, the rise is 1, 2, 3, 4. So the rise is 4. The run is 1, 2, 3, 4. The run is 4. This simplifies, of course, to just 1. It should have been positive 1. You know that this was a positive slope because as you go from left to right, it's going uphill. Next, D, I will use, starting this point, you have a rise of 1, negative 2. So your rise is negative 2. Over 1, your run is 1. Negative 2 over 1 really simplifies to just negative 2. And that should have been the slope. I hope you got those right. Now we're going to look at the second method for how you find the slope, which is using the slope formula. So before I told you that slope is rise over run, which is true. But what that means is rise is how much does it go up or down. And so the way that we can figure out how much it goes up or down is we subtract the y values for the different points. The run is how much it goes left to right, and so to find that out, we can subtract the x values for the different points. And that's where we get this, which we call the slope formula. And I ran out of space, but slope formula. And so even though we're looking at a graph right now, the advantage of using the slope formula is you don't need to. If you know the coordinate pairs for the 2 points, you should be able to find the slope of the line. So let me find the slope of A, B, C, D. Let's call this line F. I will start at this point, and I'll go to this point. This slide should look familiar from before, but now I'm going to find the slope in a different way. So first I'm going to label my points. This point is at negative 3, 0. The second point is at 0, 1, 2, 3, 4, 4. And so I'm going to find the slope between those 2 points. I'll label my x values. This is the x value of my first point. This is the x value of my second point. This is the y value of my first point. This is the y value of my second point. And then I'll plug them into the formula. y2 minus y1 over x2 minus x1. So my y2 is 4 minus my y1, which is 0, over my x2, which is 0, minus my x1, which is negative 3. And so I just need to be careful with my integer rules here. 4 minus 0 equals 4. 0 minus negative 3 is the same thing as 0 plus 3 after I kill subtraction. And this has a slope of 4/3. And that's my slope for this line. Next, I'll find the slope for this line. We'll call this G. And in order to do that, I will use this point on the y-axis and this point on the x-axis, although again I could use that point. They're all usable points to find the slope. So I'll label them. This point here is really 0, 1. And this point over here is really 1, 2, 3, 4, 5, 6, 7, 8, negative 1. I'll label my x values. This is the x value of my first point. This is the x value of my second point. This is the y value of my first point. This is the y value of my second point. And then I will plug them in to find the slope. y2 minus y1 over x2 minus x1. y2 is negative 1 minus y, y2 is negative 1 minus y1, which is just 1, over x2, which is 8, minus x1, which is just 0. And I'll simplify to figure this out. Just need to be careful with my integer rules here. Negative 1 minus 1 is the same thing as negative 1 plus negative 1 after I kill subtraction, which is really negative 2. 8 minus 0, well that's just 8. And this simplifies to negative 1/4, which is exactly what I had before. So the slope of this line, again, is negative. I know that it's negative because it's going downhill from left to right, 1/4, which means it has a rise of -1 and a run of 4. So even though we're looking at a graph, you can see that I actually didn't need the graph to do this. All I really needed were the coordinate pairs to be able to find the slope of that line. The coordinate pairs to be able to find the slope of the line, which has its own set of advantages. Okay, I'd like you to try some guided practice. So what I want you to do is to find the slope of this line, A, B, C, D, F, G. I think we'll call this line H, and we'll call this line I. And for H, I'd like you to use the point 0, 0. That'll be your origin. And the point 4, 4. For line I, I'd like you to use the point 2, 2, which is that point there, and the point here, which is at 5, -4. I think. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yes. Please stop the video here. Press play after you found the slope for both lines using the slope formula. Okay, you've tried it, so now it's time to check your answer. First, you should have labeled the x values. This could be x1 and y1, the x value and the y value for your first point. This could have been x2 and y2, the x value and y value for your second point for line H. If you plug those in, y2 is 4 minus y1, which is 0, over x2, which is 4 minus x1, which is 0. If you subtract, that's 4 over 4, which, just like last time, is a slope of 1. That's what you should have had for H. Now, for I, you should have labeled the values as x1 and y1, x2 and y2. To be fair, you could have swapped them and also said that the first point was x2, y2, and the second point was x1, y1. But this is the one that I'm picking. And then you plug them in. y2 is -4 minus y1, which is 2, over x2, which is 5, minus x1, which is 2, and you simplify. -4 minus 2. Got to be careful with the integer rules here. That's really -4 plus -2, which equals -6, over 5 minus 2, which is really the same thing as 5 plus -2, which is 3. And this simplifies to -2 over 1, or just like we had last time, because it is the same graph, -2. And -2 should have been your answer. Okay, at this point you've had guided practice for how to find the slope using the counting method, and then how to find the slope using the slope formula. It's now time to find the slope using both ways for independent practice, so this is what I'd like you to do. Please find the slope for these 3 lines. We'll call this line A, this line B, and this line C. I'll give you the usable point here on the origin, and the usable point here for A. I'll give you the usable point here, and the usable point here for B. And I will give you the usable point here and here for C. You can do all 3 of those using the counting method. Then I'd like you to find the slope for D and for E, specifically using the slope formula, which means you're using the formula y2 minus y1 over x2 minus x1. If you find the slope correctly for 4 out of 5 of these, you have mastered this and are ready to retake objective assessment 3B.2 through 4. Good luck.